let's find some derivatives that involve the hyperbolic functions. So here I have two problems, and we'll do one more at the end of the video that's not quite on the board yet. But here I have y equals t squared times the hyperbolic tangent of 1 over t. So right away I see that I'm going to have to use the product rule. The derivative of y is equal to this first function times the derivative of the second. The derivative of hyperbolic tangent is hyperbolic secant squared. And here I need to use the chain rule. So the derivative of 1 over t minus 1 over t squared. I'm really thinking about this as a t minus 1 becoming a minus t to the minus second. But I'm writing it like this because I think it'll be easier to deal with in the end. First times the derivative of the second plus the second times the derivative of the first. Well, the second function, the hyperbolic tangent of 1 over t, times the derivative of t squared, so just 2t. Here in this first part, I see that these t squareds would cancel. I'm going to write this positive part down first, though the order here doesn't really matter. And there's our nice happy derivative. In our next example, I have y equals the natural log of the hyperbolic cosine of z. So let's take a derivative. So taking the derivative of the natural log of u, thinking about the chain rule, I'll get 1 over u times the derivative of u, so 1 over cosh of z, times the derivative of cosh is sinh. And hey, there I have the hyperbolic tangent of z, sinh over cosh. All right, one more example in this video of taking a derivative. I have an inverse hyperbolic function, and we actually haven't talked about these in class, but I can find this derivative just thinking about what inverse functions do. If the inverse of hyperbolic sine takes x to y, it means sinh has to take y back to x. And because I know a derivative formula for sinh, I'm going to proceed from here. The derivative of sinh is cosh of y times the derivative of y with respect to x, thinking about the chain rule. And then the derivative of x on the other side is 1. I'm thinking about differentiating implicitly here to find a formula that will work. So let's see what I end up with here. I end up with dy dx is equal to 1 over cosh of y. Well, I'm in a moment now where I have technically found the derivative of the inverse function for hyperbolic sine, but it's not in terms of the variable x. So I want to rewrite this in terms of the variable x. This same kind of thing happened the first time we took the derivative of sine inverse back in Calc 1. So how am I going to rewrite this in terms of the original variable x? Well, I'm going to think about that hyperbolic identity we know, that cosh squared of y minus sinh squared of y would have to equal 1. And I'm going to solve for the cosh part. All right, and I end up that the cosh of y is equal to the square root of 1 plus sinh squared of y. Sinh of y is equal to x, so this is how I'm going to get my x back involved into this equation. So, the derivative of the hyperbolic sine function's inverse is 1 over the square root of 1 plus x squared. All right, 3 derivatives thinking about our hyperbolic functions.